All right, it's time again for the SMC Journal podcast, where it's all about performance engineering in IT today. And I'm Scott Moore, your host. This is the last of a four-part series that we're doing on load testing fundamentals. And we've talked so far about, and this has actually been over a 2-week period, what is load testing? What problem does it solve for the business? What's a methodology that you can use and reuse for many different projects in many different ways. We've went through the various 4 stages. We're on the last one, which is analyzing and looking at the test results to validate test results and find out, do we actually meet the objectives of a test? Does the testing do what we think that it's going to do? And more importantly, does it help the business make a decision on whether to go or no go, or their showstoppers or that type of thing? So in today's episode, I really want to focus on that final report, that more than just the tool analysis, the stuff that comes natively out of a tool, but I can't really separate the final report that we run from the analysis that comes out of a load testing tool. And a lot of the stuff that is in a load testing tool natively would be like end user timing, stopwatch timings, I would call that. How long is a page taking to render from an end user perspective? What's the call from a network level, and what's like a full browser rendering or full page rendering? Those are easy. What are some other metrics that need to be in your analysis? Well, we can't separate monitoring from analysis. So that's what we'll talk about today, which is monitoring and analysis. So back to the basics on load testing fundamentals today on the podcast. So before we go any further, let's talk about the great sponsors that make this show possible. And that includes Micro Focus, makers of LoadRunner Professional, Enterprise, Cloud, and Developer. Micro Focus has the largest community of performance engineers in the world. Performance matters to them. You can join their community at community.microfocus.com, scan that QR code, or check out the links that we have on our show notes. That includes the link to the performance engineering page for the LoadRunner family, as well as a performance playlist on YouTube. We're also sponsored by Supervisor.com. Stop losing money with a slow website. With Supervisor, you can continuously track the performance of your code and your hosting, predict site page load speed with higher user volumes with an easy one-click load testing solution, which you can find out more about at supervisor.com. And Lori Casti, thank you so much for sponsoring this podcast and being part of this show. We really appreciate it. I hope in a future episode, we're going to have either show you supervisor.com, which we haven't done yet, or it's coming very soon. So I'm bugging Lori about that right now. So we're also sponsored by StormForge. The StormForge platform focuses on AI-powered software that's designed to help your DevOps team release with confidence. It also helps your IT leaders realize the promise of being cloud native, which should be faster innovation, higher quality, resiliency, scalability, and efficiency. Things that everybody wants. You get that in the StormForge platform. So check them out at stormforge.io. And again, thanks everyone of our sponsors for sponsoring the SMC Journal podcast. So back to our fundamentals class. Let's wind this down with talking about analysis and what goes into analysis. So we already know that load testing is going to generate load, and while under load is going to be gathering metrics. Those metrics will include end user timing. So what is the end user experience under this amount of load? Under 1,000 user test, how long does it take for a page to render, which includes the request, like you log in, hit your password, click enter. How long does it take for the whole round trip to happen across the network, across every tier, come back, and then render to your screen to where it's actually usable? There's a whole group of knowledge base around front-end website analytics around performance, right? So I would call that front-end performance for the web. And that's when we get to start, that's when we talk about Google Lighthouse and the analytics that come from that, GT metrics, some of those things that talk about how to optimize your page once you've loaded all these resources. And we get into CDNs and compressing images and things of that nature. On the back end, we talk about do we have enough network? Do we have enough bandwidth? Do we have enough throughput? Do we have enough CPU and memory and disk and network? We have enough resources to actually accomplish these tasks with this number of users or this volume that we're pushing through the system under test? Well, if you take a load testing tool out of the box and just run it with no monitors, you're running blind, because what will happen is you'll get a timing that says, okay, I did a search on this web page and I'm doing a different search with dynamic data every time, but every time I do it, it takes 12 seconds to come back, which is too long, right? We want 5 seconds, 3 seconds, whatever your SLO is. Hopefully 12 seconds is not good for you, because your users will abandon quicker than ever now. They have no patience whatsoever and they expect a pleasant experience. But if it is 12 seconds or it is higher than you want, there's a problem. So the next question that you're going to be asked as a performance tester is, why? And if you don't have any additional metrics to go by, how can you know? Well, I know what I'll do. I'll just ask the system administrators. I'll ask the database administrators. Well, they're looking at something on their side to tell you, well, you know what? The reason that might be slow is because we're spending a lot of time in the database because we've missed an index. Or the network person may say, you're pulling down a whole bunch of stuff that we shouldn't be, or we're not, we're using up all of the network, and pages are too large in size, or something of that nature. When this happens, you know, they're looking at one thing, you're looking at just these timings, and then there's kind of gets to be this like a, you know what, you just run the load test and you just tell us what the timings are, and we're the great Oz back here and we'll figure out what all this stuff means back here. You just do your... No, that's not the way it's supposed to be. We're supposed to be working together, but it would be nice if we could see everything together in one kind of central place. I know that sometimes it's not easy to get permission to monitor external systems, right? That's getting easier and easier all the time, but you're going to have a problem generally if you go up to an Oracle DBA and say, I want to just tap into that Oracle database and start monitoring a bunch of things on it. And they're going to, the first answer is no. Then it's going to be heck no. And then it's going to get worse from there. You're probably going to have to escalate that, and then they're going to be asking, why would you need to do this? And you have to explain there's a valid reason why I would want to monitor system resources and various tiers of this application under load, because I want to cross-reference that data to pinpoint exact points in time and realize certain patterns as fast as possible. So this is when effective monitoring comes into place. Now at this point, I'm really not talking about observability or trying to grab every single thing you can from every single tier. It would be nice if you could do that, but sometimes that ends up, number one, being so much data you can hardly parse through it and figure out what it all means, and harder to reduce the noise that's out there that you need to bring forth the stuff you only want to see. So there's a big filtering process that goes on there. So typically what I recommend is a best practice as follows. I would start with, now we're talking about back-end performance testing. We're not talking about the shift left stuff, although you could monitor this same stuff as early as possible. I do recommend that you do that. But right now I'm just talking about tried and true integrated load test of an application, and with everything, all business processes and everything combined, as if you're creating what would happen in production in a typical peak hour, right? While that's running, I want to grab the main system resources that come from CPU, disk, memory, and network. The main thing being, I really want to know when the CPU begins to queue. I don't necessarily care that CPU is at 90% for 10 minutes, as long as we're not queuing. But as soon as you breach 100%, and then and some applications are made to take advantage of the CPU 100% of it all the time. It's when you actually get into the CPU queue, when you start getting above 2, that all of a sudden you will notice that transactions start slowing down very, very rapidly, because it just can't keep up. So think of a turnstile where it begins to get backed up so far it just can't continue to process. So that's one of the most common problems. Or if you run out of memory, then it has to go to disk to get the information and store that information temporarily, which is much slower, and so everything just tends to slow down. I've also seen where you grab all these metrics that are listed here, CPU, disk, memory, network, and nothing's wrong. And the thing just keeps getting slower and slower and slower, but the servers aren't working. Well, did we miss a server? No, you monitor every server, and it's still, there's nothing wrong. And that's when it could actually, at least you know what it's not, when you can prove that these servers have resources that have not been depleted. I've seen situations where the code itself had these what they call critical stages or critical stops, or I think of that like a turnstile in a subway station, where this code has a critical junction point where it has to run, stand alone, move everybody out of the way. I get to go through the turnstile with nobody else messing with me, and I want to take as long as I want. And when I get through, then you can do everything that you want after me. There are situations where that comes into play, and so it's not necessarily that the system resources are being utilized, it's the code is behaving in a certain way, and to be able to isolate that, if all you saw as the load increases were timings that were getting higher, you might assume we're running out of CPU or we're running out of resources on the back end, which may not be true. But the only way you're going to know that is if you have a 360-degree view where you're looking at all these things. Now, some of these systems today are so complex, I mean, and they have so many tiers now, and I think about complex SAP implementations, for example. There's 8 or 9 tiers sometimes in this, and there's translation between certain systems that go back and forth. And any one of these points can be a failure. A load balancer sitting in front of something, a hardware device, firewall, any of that stuff can be a bottleneck. So you need to be able to monitor the main tiers of it, but that doesn't mean that you have to monitor every single thing in the tier. So don't over monitor. Stick with key metrics that will get you. Now, I say this all the time, and I know this is kind of from my southern United States upbringing, where we talk about farming analogies, and we talk about the needle in the haystack, the virtual needle in a haystack. And I've always used this, and I just assume everybody knows what I'm talking about, is if you have a farmer who's got stacks of hay, right, and you're trying to find the needle in the haystack, well, the first thing you would want to know is which haystack, because there might be 10 haystacks. We at least, if we can get to the haystack, then we can worry about the needle after that. And I think that's the way monitoring should be, is if you've got an N-tier system, or even if you've got, not a monolith anymore, but you've got microservices and you've got containerized applications where it's always dynamic and switching, you still need that kind of traceability to find out, well, what area of the haystack are we dealing with? Once we can focus on that from these general metrics, then we can begin to dive deeper on that single haystack and start grabbing, if it's a Java application, start diving into the JVM and look at all the garbage collection and look at all these things that you wouldn't necessarily look at if that weren't the problem. If you don't think the code is the problem and you think the server, database server is running out of CPU, well, then you can focus on that server and get deeper in that, monitor the queuing levels, monitor some other things around it, and find out what's going on. So just know that you don't have to monitor everything, but you deep dive once you find the haystack that's the problem. Don't just do that. This is my opinion. And again, when I'm showing you this, these are my best practices. These are things that work for me. May not necessarily work for you, and if they don't, do something different and make this better if you can. The typical monitors, if it was a Windows-based system, where you've got a IIS-based web server with SQL Server on the back end, and IIS has the logic built in with .NET on the same server, those are the type of metrics I would get. I would get the Windows operating system. I would get some .NET metrics. I would get some SQL Server metrics from the SQL Server, all using Windows perfmon, pulling that in with my load test end user timings and correlating the data. If it's a Unix-based system, you might have to use something like rstat, or IOStat or any of the stat things and pull those in at the same time and start looking at those top. There's many different ones, SAR, that you can look at, but the main point is pulling those metrics, whatever that type of operating system, whatever that app is. So if it's Java, you want J2EE components. There might be a WebSphere application server, for example. You might have specific metrics to monitor WebSphere by itself. Now, I would probably not go there first. I would probably go there second. If I found out that the system resources were being affected, I probably would then do a deeper dive on that server after that. But if I'm going to grab WebSphere counters, it's probably going to be just a handful, like 4 or 5, just the main ones, and then I'll dive from there. And also just general network conditions as well. You want to know that the network itself is not a bottleneck, which these days is not typically the case, because over many years, network administrators have been beaten so much because anytime the system slowed down, they blamed it on the network when things got busy. So they continued to order more and more pipe. Their tools at monitoring the network got better and better and better. So they have a pretty good handle on what the network is doing, and they can prioritize traffic better now. There's lots of power tools that they're using today that they didn't have just 15 years ago or so. So once we've got these monitors, the right level of monitoring, and we've started finding this information, this is where we talk about how we do reporting. So the initial reporting that we have is typically from the tool itself. And this is why you always hear me, James Pulley, and others saying the analysis that a load testing tool provides, whether that's natively, like something LoadRunner would have, or if it's an add-on capability on an open source load testing project, whatever it is, it's critical that that analysis be good enough to present to the business at some point to help them make a decision, not just a bunch of lines on a graph that may or may not make sense to anybody. So it's really key that you think about how you're going to present this information. Now, we would prefer to have continuous load testing, shift left load testing. It all runs in a pipeline, it's all maintained very well, and the tool itself presents the results and checks. There's a check that's automated, and then really only people need to be notified when there's a real problem. But when we're talking about some of these larger scale integrated load tests, there has to be a manual verification for this. I talk to companies like, say, MongoDB, and I talk to my friend David Daly, and they've built their own load testing solutions and performance solutions in-house. There's really smart people that work there, and they can build this stuff easily. However, as automated as they want to be, they know there are certain points in their process where they have to have a manual validation in these performance results. They have to stop at some point and say, let's look at this. Let's make sure something didn't slip through the cracks. And they continue to improve that process so that their algorithms look for differences in runs, not just if something is taking longer or not taking as long. Well, if it doesn't take as long, it passes. Not necessarily. If there's a difference between a timing, they look at it. And so as they get better with that, reporting gets easier, it gets more streamlined, but there are some companies that just aren't there yet, and they can't build this themselves. So for smaller tests, shifting left, daily test, or something where you're having to report on a very short-term basis, and we're talking about a smaller scope. We're talking about one business process or maybe just a couple of functions, and it's running every day. You might have a dashboard that's being built automatically where the output from an automated pipeline gets pushed into a time series database. There's a visualization that happens. There's a PDF that's generated, or there's a graphic that's generated, and it just gets put into some kind of a system that you see, or a dashboard somewhere where people can look at, and there's an alert added to that. But if you have to manually kind of create something from that, I just recommend thinking of it in terms of a red light, green light. So I call this the flash reporting, right? So what we're concerned about there is just reporting the basic facts around scalability. How far can we push this before things begin to topple over? Reliability, can we introduce some kind of chaos or something that we didn't expect and it still kind of stays up over a period of time. And end user experience. Are we still meeting the end user experience even, and the system level resources are under whatever threshold we've said are acceptable? So I would do this red light, yellow light, green light thing, and I would put whatever your SLOs for your company are, your service level objectives. Now, service level agreements are something different. Service level agreement is a hard contract between companies. If this doesn't perform as designed and as advertised, we don't have to pay for this, and you're in breach of contract, and there could actually be lawsuits involved for breach of contract. Service level objective is more informal in the sense that this is what we're shooting for. We're trying to figure out if we can meet that, and if we don't, we're going to do something about it. But an SLO will probably follow an SLA very closely if they have to meet that, and so they're more stringent if there is an SLA involved. But an SLO by themselves can be set by the company, set by the department, set whatever. And there's now a whole series of conversations around service level objectives right now in the monitoring observability space. There's even a conference called the SLO conference, the SLO conference. So there's a lot of talk about this right now. I just create a very simple report that measures these things and report it to the business. Sometimes that's in an automated fashion. Sometimes it's in a PDF document. Sometimes it's a Slack generated message with a graphic on it. And sometimes it's just a Word document that I print out and bring to a meeting every day and show everybody. And they go, yep, cool, let's go. Everything is dependent on the situation and maybe the client and where they're at in their process and their maturity level. But then sometimes there's this bigger integrated test that you have to run. I mentioned like SAP, like you're testing a huge module within SAP and you need to find out how that works. And there's a lot of moving parts and it takes a long time to run some of these tests from creation to end. And sometimes you need to have two different audiences and you need to build a document. Now, I'm not necessarily saying that, okay, I wouldn't say that when the Agile agenda basically says, you know, we value this over that, and one of the things has to do with documentation. Trying to word this properly. I realize that true Agile doesn't just take documentation and throw it out the window. It's useful documentation, and I'm all for useful documentation. Sometimes I go a little bit overboard and provide too much documentation because I want to, as a consultant, I have a little bit of, I got to cover myself in my documentation because I know there's sometimes a tendency for people to blame the product that's being used or the product operator that's using it and come up with an excuse as to why something they might not be getting the results that they want. And we always talk about calling your baby ugly. Nobody wants their baby to be called ugly. Nobody wants to work on an application and be told that it's not performing well or it's not good. And so there's a little bit of consulting tact that has to go along with this. So I will provide a report if it's sort of like, I'm thinking of an engagement, right? When I'm doing a consulting engagement and I have to be walking out the door very soon, I want to leave them on a really good note where they have enough documentation from these results. So you've got the detailed test technical analysis that's from the tool. I just will summarize some of that for the technical folks that are part of this. But then I'll also tie that back to the business objectives, and I'll have a document that summarizes. It could be a slide deck. It could be a Word document. It could be something else. But it basically says, here's what we did during this testing. Here's what we found. Here's how the team worked together to either fix this, or here's what we think we should do about it. And this is the thing the business needs to know about this application from a performance perspective. And in my opinion, it should have specific recommendations coming from the performance engineer. And this is where we get into a little bit of a like role-based type mismatch sometimes. I don't know if the right word to say here, but there are some companies who assume that they're going to hire a performance tester and that person is just a tester. In other words, you just take this round hole and put it in put this round peg, put it in a round hole. That's your job. So you create the scripts, you run the test, you send us the results, we'll take care of the rest. You keep your mouth shut. I hate that. I hate that attitude. I don't think that's right. And I think a lot of companies have stopped doing that, and I think it's a great thing. But I also think that sometimes there are people doing this job that aren't necessarily as skilled, and they are not as confident in their skills. So they have confidence in the tool. They can run what they were told to run, do what they were told to do, but they can't offer any recommendations on how to improve it. Well, I can't be an expert in the tool and run a performance test and be an expert in whatever. Well, no, you don't, but there should be some general knowledge of the application that you're testing and the stack that you're testing. And as you get more experience, you'll experience more of the tech stack. For example, I have to go from running an SAP load test, this engagement. Next, I'm running a Citrix deployed application. Next, I'm running a load test against a green screen mainframe application. And then I go back to microservices, containerized, Kubernetes, cutting edge, gRPC, whatever the thing is today. I can't know everything about that. I can't know everything about the differences between SQL Server and Oracle. And so I leave the deep expertise to that person who's over that tier. So the Oracle DBA should know everything it needs to know about tuning the Oracle database, much more than me. As I have more experience with applications that utilize Oracle, I will learn over time, and I'll take notes and I'll keep them. And I have, and after about 25 years, you come up with a lot of notes. And I'm sure some of you will too. But that's why you're working with the team as you're doing this testing. You're not doing it in a vacuum. You're not doing it in a corner. You're involving them so that when you do hit something and you suspect that it's the database, you work with the DBA and the database team and you fix the problem, or you try to fix it, or you tune the problem. That gets documented. The main point, not every single change that was made to the database until you got to the fix, but in this final report I'm talking about, it would be, I worked with this person and we found this, we fixed this, and this was the difference that it made. That's what the business wants to know. Did you improve it? Did you make it where it would work and that we can roll this thing out and there's not a problem with it? And that's how that gets done. It's important that when a report like this is presented to the business, that there is no he said, she said, non-personal. You want to keep everything non-personal and very neutral. The way I describe this kind of reporting is it's almost like you as the performance tester were walking to the meeting today. You happened to walk past a printer that had something printed out. You don't know how it got there, and you want to show everybody. There's no blame being pointed. You're not saying, that person couldn't code their way out of a paper bag and you couldn't, it's not like that. But getting back to what I was talking about, there are some companies that still feel that the performance tester should just report what the tool says, get it set up, put it in a pipeline, and just maintain it and leave the analysis and the improvement to the developer. I really feel like if that's the difference in moving into a performance engineer, is that your final report or a report should have specific recommendations for the developers. Yes, I know developers think they know every single thing that's out there. No, most developers don't think that. There are a few though. I've met them. I know that they exist. But I think developers in general, they want to have this team level experience. And I think a lot of developers, especially developers who have not had decades of experience developing enterprise applications, they're going to tell you, look, I know my thing here, and I might understand performance about the code that I'm writing for this module, but they may not understand what you know about performance about the system as a whole. And all of your experiences of testing that Oracle app that time, and that SQL Server database that time, and the Java app that time, and the .NET app that time. You have, over time, you will build this experience that will allow you to bring a lot more to the table, where you can say, I've seen something like this before, and this is how we fixed it before. We should try this. And And that's what I feel like the value is for a performance engineer to be doing testing. And I don't think a performance tester is limited to that. I believe that that's what a performance tester should do too. The performance tester, whatever you call the title, they should be reporting that information back. I've spent a lot more time on that than I thought that I would, and I feel like I've got on a soapbox, and I apologize for that. But that's if I had more time with all of this, the podcast, and I've been talking on all of these past 2 weeks about possibly building a class. I got a lot more slides to show you. I got a lot more information to share with you. Just don't have the time to do it. So that might be a place that we get into that. But in general, you want the right level of monitoring and you want the right level of reporting. The level of reporting that I'm going to give to the development team about a feature that just got put out, that I'm just testing that, shifting left, running a 50 user test to smoke out any, low-level problems that we see, versus what I'm going to present to the business at the end of a large SAP test, for example. Totally different kind of reporting. So you got to know your audience and you got to know the right scope of and depth of reporting that you're going to give to these audiences. So just keep that in mind. A lot of this stuff, probably sounds like it's common sense, but the way I like to say this is, and I'm not comparing myself to Bruce Lee in any way, but Bruce Lee once said, and I'm paraphrasing, it's kind of like this: when you first start learning how to do kung fu, what he did, martial arts, a punch is just a punch, a kick is just a kick. So you don't know, and then you dive deep into this thing and you learn how to do these special punches, and you learn there's more than one kind and more than one kind of kick, and there's techniques to all this, and you get into all the technical stuff. That's where you start learning all this, and you start forming habits and skills, good habits, good skills, from doing it so much. And then at the end you get to this point where you get out of that weeds of the technical, where again you've mastered it. But a punch is just a punch and a kick is just a kick. And if somebody comes up and says, how did you do that? You're just like, I just punched him, right? But it was from all of that discipline and reiterative skills that you develop during this time. Reiterative is not the right word. I'm searching for another word there, but where you're doing it over and over and over again, and it builds this muscle memory in your brain. So like anything else. So now I'm getting into philosophy, and I probably shouldn't be doing that on this show. So I appreciate everybody who's been watching this. I think the biggest question you probably have in your mind right now is, how come Scott's been wearing the same shirt for 2 weeks? Does the guy ever bathe at all? So yeah, we pre-recorded this because I've been out on the road with the performance tour doing a bunch of meetups, and I wanted to have this set aside so that I still provide you with this kind of content even while I'm doing other things, because this is really important, and I want to make sure that you get good content every week from the SMC Journal podcast. My sponsors expect it, and I expect it. Do you expect it? If you do, I would like to know that. You can reach out to me on my website, scottmoore.consulting, my LinkedIn profile, or through Twitter. You'll see the information right there. You can subscribe to this YouTube channel if you like this content. It really helps me understand as I get more subscribers that there's interest is still growing in this podcast and that I should keep doing it. And it tells my sponsors that as well. Finally, you can reach me at help@scottmoore.consulting by email, and would love to hear what you had to say about this. So I know that I didn't cover every single thing about what you could know about load testing and all the fundamentals. So I gave you just a little bit of a taste of what I could with the amount of time that I had, but I hope you got something out of that, and I'd like to hear if you did. So write me, tell me in some way, and let's keep the conversation going. So thank you for watching this 4-part series for the SMC Journal today. This is Scott Moore. We'll see you next time. Bye-bye.